Welcome back, class. This is the lecture number 7, and this lecture is of haloarenes. So in this lecture we are going to discuss about the methods of preparation of haloarenes. We had already completed haloalkanes. Okay, so this is the next topic, that is the haloarenes. So we have several methods for the preparation of haloarenes, and we will discuss it one by one. So the very first method and very common method and important one is as well, that is the electrophilic substitution of arenes. Electrophilic substitution of arenes. Okay, so another name of this reaction is called direct halogenation. Okay, see, direct halogenation in alkyl halide or haloalkane is there, and direct halogenation for aromatic halide is there also. But you know that fluorination and the iodination is different phenomena, different behavior. So we will discuss also the nature of fluorination and iodination. So the very common direct halogenation is the chlorination. So we'll start with the chlorination first. Okay, so let's talk about the chlorination first. Chlorination. See, the direct chlorination, if I'm going to write the reaction is benzene ring, then this benzene ring along with chlorine in presence of FeCl3 at temperature of 310-320. So 310 is something like 30-32 degrees Celsius Kelvin. So this will give you chlorobenzene. Okay, this will give you Cl, chlorobenzene with release of HCl. Now there are several things to discuss. This is an example of electrophilic substitution reaction. That means here the attacking reagent is what? Electrophile. But where is that electrophile? Because it is in a substitution, it is not a addition, it is not a free radical reaction. Okay, it is in a electrophilic substitution. That means here electrophile must be there. Okay, so where is that electrophile? So here you should understand that FeCl3, the role of FeCl3, this is also called halogen carrier. That means the substance which carry the halogen, which abstract the halogen. So that is what Lewis acid catalyst, that is FeCl3. What this FeCl3 will do, this will generate an electrophile. Okay, by, see the reaction, FeCl3 plus Cl2, one of the, because it is an electron deficient compound, AlCl3, FeCl, that all are electron deficient compound, so they will abstract one of the chlorine atom from here. So here what we'll get FeCl4 negative plus Cl positive, and this is what, this is your electrophile. Okay, so that is also called a halogen carrier, and the role of this catalyst is what? To produce electrophile. Okay, now this electrophile is capable to attack on this benzene ring. We have 3 pi bond. Okay, so there is a resonance established. because if you go for the further reaction, like we have benzene ring, so benzene ring is here, and then a take of electrophile Cl plus. So Cl plus, this pi electron cloud will go to this side. Now just see the movement of electron, and this is give you a slow reaction. And then what you will get, you'll get this pi electron, I'm writing here this pi electron, and here this hydrogen and chlorine, and this is become a positive charge because the direction of arrow is always a negative charge, so this will be a positive charge. Then resonance is stabilized, so this will go to this side. So again the direction of arrow is a negative charge, so this will be neutralized and this will get a positive charge. So here we have a positive charge, here we have pi bond, then here we have pi bond, then H, and then Cl. Then again in the next phase this go to this side, so this will neutralize this plus charge and here we'll get a positive charge. Okay, so in the next stage what will happen, here this and this HCl, and this is a plus charge. Okay, so these three is a plus charge. So ultimately what we will get, we will get a collective resonating structure, and that is like this. This I'm drawing plus and H and Cl. Okay, so this is what the resonating structure of benzene. And at the final stage of the reaction, this is the first where we have what generation of electrophile. The first stage is what, generation of electrophile, and in the second stage the attack of electrophile to the benzene ring, and in the third stage, this proton, is like this. Okay, so this proton, that means the hydrogen is abstract by what, FeCl4 negative. Okay, this will abstract by, so we'll get the resultant chlorobenzene plus FeCl3 and plus HCl. So this is how the reaction will proceed in 3 stages. Okay, so if you go for the bromination, then what we required FeBr3. Okay, one more thing we can add here is that if we have excess of chlorine, if Cl2 is in excess, so what will happen, if Cl2 is in excess, we'll get the mixture of product. Like let's take an example here. I'm taking example of chlorobenzene. Okay, now if you have a chlorobenzene and you want to what you want for chlorination here, so Cl2 is the chlorination, and if it is in excess, okay, again the catalyst will be what, FeCl3. so what we'll get, we'll get the mixture of product, that is what, Cl, that means the ortho, and then the para. Okay, so this is called ortho dichlorobenzene and this is para dichlorobenzene. Ortho dichlorobenzene and this is para dichlorobenzene. So what? Because of excess of fluorine. And one more thing is there, you can separate these two also. You can separate these two on the basis of their differences in the larger melting point. Okay, so separation can also possible. Separate due to large difference in their melting point. Okay, separate, we can separate because mixture of product, getting a mixture of products is only one worry, that is you cannot separate it. So we can separate due to what? Large difference of their melting point. Okay, so this is very simple to you. And as I told you that bromination can also be done in the same pattern. There is no problem with the bromination. Bromination can also be done. Bromination, okay, same as previous, with same pattern, with same pattern. Okay, now let's talk about the fluorination and other things. So fluorination, see the reaction with fluorine is very violent. Okay, so it's very difficult to control it, and that is why the direct fluorination is not possible, and the fluoro compound formation is very difficult. Okay, because of violent reaction with fluorine, direct fluorination is not possible. Okay, let's move for the next, and that is the iodination. So this is the page number 1. Let's go for the second page. And iodination, next is iodoarenes. Okay, we can say that is iodoarenes or iodination. So iodination is also a problem. What? Because the reaction is reversible. Let's start the reaction first. Let's write the reaction. So this is the benzene and iodine, and this reaction is reversible. Iodobenzene formation is possible, no doubt about that. It will be formed, but the reaction is reversible, and that is the problem. The reaction is reversible, and Hi which is produced is a strong reducing agent. So this will reduce iodobenzene back to benzene. Hi is a strong reducing agent, so it will reduce iodobenzene iodobenzene to benzene. Okay, so we have to stop this reaction. So in order to stop this reaction is carried out in presence of oxidizing agent. To remove this reaction is carried out in presence of oxidizing agent. Okay, so first what will take an oxidizing agent, so Hi plus HiO3, this is called periodic acid. No, this is not periodic, this is iodic acid. This is iodic acid. Iodic acid. So here iodine is in +5 oxidation state. HiO4 is periodic acid. Okay, so this will give you iodine plus H2O, and this iodine, you can balance this reaction. So here oxygen 3 will take here 3, okay, 6, and iodine is twice, so here 5 you can take, and twice is here, okay, no, it's complete 6, okay. Reaction is balanced now. So this iodine will not take part for the iodination, okay. This iodine first, this is a strong oxidizing agent, sorry, reducing agent. It is an oxidizing agent. It will neutralize and it will liberate the iodine, so it will not the reverse the reaction, okay. So this is the preparation of haloarenes by the method of substitution of arenes, electrophilic substitution or direct halogenation, okay. Let's go for something else in this particular section, and that is preparation of aryl alkyl, okay. So preparation of aryl, sorry, it's not correct, ar aromatic alkyl I'm talking, okay. Alkyls, ARALKYLS. So let's start the preparation. For that we will take what, toluene, okay, chlorination of toluene. So let's start the example. We have a toluene CH3 and chlorination. So this chlorination can be done sunlight, and this will what, simple, one of the hydrogen will, earlier the benzene, so we have the hydrogen from benzene, but here we have substitution of alkyl group, so here hydrogen will be removed from alkyl group, okay. So what we'll get, CH2Cl, okay, with HCl. Now again the thing is what, if this chlorine is in excess, if this chlorine is in excess, so what will happen, if this chlorine is in excess, the reaction will continue. So CH2Cl, CH2Cl plus Cl2, again with the same condition we'll get CHCl2, okay, plus HCl, and then in the next stage we have CHCl2 with chlorine, and this will give you next, that is CCl3 plus HCl. Now no more hydrogen is there, so the reaction will stop here, okay. So this is what this reaction will continue. And again the name, you should remember the name also. So this compound is what, this is the chloro substituent, okay. So the chloro and phenyl, and this is what, this is the methane, okay. So this is chlorophenyl methane, chlorophenyl methane. And the very common name of this compound, you should know this also, that is called benzyl chloride. This is very important, okay. I'm writing benzyl, BENZYL, benzyl chloride. So the common name is benzyl chloride. And this, so what is the name of this compound, this will be benzyl dichloride. This will be benzyl dichloride, benzyl dichloride. Okay, and other name you can write is what? Dichlorophenyl methane. Like this is chlorophenyl methane, so it will be dichlorophenyl methane. This will be trichlorophenyl methane. This will be tri I will write here. So this is what? Trichlorophenyl methane. And the other name is what? Benzotrichloride. Benzotrichloride. So you should understand that this is what? This is benzyl, YL. This is AL, benzyl, and this is benzo. Okay, so this you need to understand. You need to remember that one chlorine is YL, two chlorine is AL, and three chlorine is benzo. Okay, so this is all about from this lecture. Here we have discussed only one method for preparation, and that is the electrophilic substitution reactions of arenes or direct halogenation. Okay, we'll take some question, probably one question, and you just go through that question and go for the solution also. Okay, so let's write the question here. So first question number one, just complete the reaction. Okay, so reaction is for you is this is the substituent CH2CH3, and this is the substituent that is NO2. Okay, and in presence of bromination you have to done with heat or light. Okay, so what is the product? This is the first question for you, and the second, again you have to complete this reaction. So question number 2, again you have a this is CH2OH and OH with HCl and heat. So what is the uh, result? What is the product in both cases? You have to answer this question. Simple question. I think you can solve it very easily. So go for it and write your answer in the comment box. Okay, and if you have any query and doubt, just ask your query and doubt in the comment box. Thank you so much.